We're picking up at postnatal bone growth. And so this is basically what all of you are going through. You're getting taller. And so this is growth in the length of your long bones. And so take a look. We're looking at the epiphyseal plate or the growth plate here. And you can see that we've got cartilage cells up here, and then we've got bone down here, so ossification versus cartilaginous. And you can see that my boxes here are across the epiphyseal line. So what you find out is that the cartilage on the side of the epiphyseal plate that's closest to the epiphyses is relatively inactive. And then cartilage abutting the shaft of the bone organizes into a powder that allows for fast, efficient growth. And so the cells up the epiphyseal plate proximally to the resting cartilage form three functionally different zones. You have a growth zone, you have a transformation zone, and you have an osteogenic zone. Now, in the growth zone, and you can see I'm up here, here's my growth zone up here, okay? And what we're seeing is that cartilage cells are undergoing mitosis, and they're pushing the epiphyses away from the diaphysis, because what's happening is your epiphyseal plate, when those cells undergo mitosis, it thickens. And so that's what you're seeing here in this zone, okay? Now, in the transformation zone, these are older cells in large, and the matrix becomes calcified. The cartilage cells then die, and the matrix begins to deteriorate. And so that's what you're seeing in these older cells here. They're dying, they grew, they died, and now they're starting to move out of the way. So you end up with this osteogenic area down here, where then new bone comes in, and you have this bone formation occurring. So we see bone growth in length, and that's that cartilage continually grows and is replaced by bone, is what I was showing you here in figure 6.9. And then we also see bone remodeling, and this is where bone is reabsorbed and added by appositional growth. And so we can see that it looks like this. So take a look at this. This is figure 610. Basically, it's exactly what I was just showing you. Here on the epiphyseal plate, we get cartilage that's growing on the top here, and it's pushing things up. We also see cartilage growing up here and pushing up. And then the old cartilage down below here, this is dying and cavitating out, and it's being replaced by bone here. And then same thing down here. So that's how this whole thing moves up. But keep in mind that if we don't have remodeling going on, remodeling is we're going to reshape this thing to make it fit. If we don't remodel it, we're going to have these clubs at the end of our diaphyses. These epiphyses will look like great big clubs at the end. So it's important that we have remodeling going on, and that's where those osteoclasts come into play. So that's important to know and to understand. Now, when it comes to bone growth during infancy and childhood, the epiphyseal plate, that activity, that's all stimulated by hormones, okay? And then during puberty, you also have, testosterone and estrogens. That promotes that initial adolescent growth spurt. It also causes masculinization and feminization of specific parts of the skeleton, because our skeletons are different between male and female. And then later, those hormones play a role in actually causing the epiphyseal plate to close. And that ends that longitudinal bone growth, is once we stop this. So when it comes to the remodeling then, osteoblasts, osteoclasts either reabsorb or they build, just depending on which surface they're working on. Now, when it comes to bone deposition, this occurs when the bone is either injured, or we need to add strength to a certain part of it, so we have to add more bone material to it. This requires a diet rich in protein, in vitamin C, D, A. Of course, you need calcium and phosphorus, but you also need magnesium and manganese. So these are all that are essential for the mineralization of bone and getting bone to to uh, to grow, to remodel, to change. Okay, when it comes to bone reabsorption, I've said before this is accomplished by the osteoclast. Um, there's all sorts of mechanisms that go into play here. I'm not going to go into those, but what I do need you to know is why. Why do we have osteoclasts that break down your skeleton? Well, if you have low calcium, this is going to come into or affect negatively the transmission for nerve impulses. And you'll see that when we get into the nervous system. This will negatively affect your muscle contractions. Your muscles won't contract without calcium. Your blood won't clot. Your glands won't secrete. And cell division then is also not effective. So calcium is vital when it comes to your body. So we have a couple controlling models. Here's what they look like. So these are my two control loops to regulate bone remodeling. Hormonal mechanisms maintain that calcium homeostasis in the blood. And then we also have mechanical and gravitational forces that act on the skeleton. They also come in and play a role. Okay, so what you're looking at here is you're looking at blood calcium levels. So let's go to the top here. In this case up here, we have an imbalance. My imbalance is we have rising blood calcium levels. And this is going to trigger my thyroid gland here. Here's my thyroid. And it's going to release a hormone called calcitonin. Okay, so calcitonin then stimulates calcium salts being deposited in the bone. So because I've got too much calcium on my blood, I have to put that calcium into my reservoir here, which are my bones. And so that's what's taking place in the upper part of the loop. The lower half down here, this is in case this is more likely for us to happen. We have calcium levels that fall. So we need calcium in our blood. Well, again, if we don't get it from our diet, our body's going to take it from our skeleton. And that's exactly what happens here. Your blood calcium levels fall. This stimulates the parathyroid gland. By the way, the thyroid gland lies down here in your neck. Your parathyroid glands, that's that 4 little nodules there. That's in the back side of the thyroid gland. That's why it's called the parathyroid gland. Completely different gland though, because now instead of releasing calcitonin like we saw up here from the thyroid, now we're releasing PTH, which is parathyroid hormone. Parathyroid hormone then stimulates the osteoclast to degrade bone, to break down the matrix and release that calcium back into the bloodstream, bringing the levels up where we need. Now, this is all just based on blood calcium levels. What about my comment before where I said there are other factors that play a role in your calcium, or that play another role in your skeleton? And that's the mechanical stresses that you place on your body. Okay, we have to respond to that. If you're in a position where all of a sudden you gain weight, your bones have to react to that. You can't put a lot of weight on skinny little bones, they'll break. So there's something called Wolff's Law, WOLFF, Wolff's Law. And what this says is that a bone grows or remodels in response to the forces or demands placed upon it. So in other words, the observations supporting this law basically say this: long bones are thickest midway along the shaft, where bending stress is the greatest. Okay. Secondly, curved bones are the thickest where they are most likely to buckle. So this is kind of hard for people to understand, that if I put more pressure on my skeleton, if I gain weight, my skeleton's going to get thicker. If I lose weight, the same thing, the opposite's going to happen. Once I lose weight, my skeleton then is going to follow. So you hear people talk about being big boned. I'm sorry, I don't buy that, because Wolff's Law says that your skeleton is going to respond to the stress that you put on it. Last part of this chapter that I want to cover. This is figure 1613, and this is what happens when you break a bone. Now, keep in mind that the cells involved here are still going to be obviously osteocytes, because those are mature bone cells, but a lot of osteoblasts and osteoclasts. But right off the bat, we've broken our bone here. You can see my medullary cavity there. So I broke in the compact, and so the first thing that occurs is I get a blood clot in here, which is called a hematoma. So that's first and foremost. Once I have my hematoma, then I'm going to start seeing some blood vessels form across again, and hopefully we don't have a lot of vascular damage. That's a concern, by the way, when it comes to breaking a bone, is to make sure that we still maintain our vascularity in the limb or whatever it is we've broken. So we got to make sure that we still have good blood flow. If we have good blood flow, what we're going to see then is we're going to start seeing this callus form. And in this callus, we're going to start off with some cartilage and some other tissues like collagen fibers, and stretching across and filling this area in. As the new blood vessels form, we're going to eventually change that callus, that fibrocartilaginous callus, into a bony matrix, like what we saw in endochondral ossification. We'll cavitate out one, we'll put the bone in the other. And the bony callus is going to take place, and then you can see down here that we've got a healed fracture. Okay, so those are the steps to healing a broken bone. I want to show you quickly when it comes to broken bone. Of course, we get that the older we get, the more likely that happens because of osteoporosis. My figure 16.14, my figure 6.14 here shows osteoporosis, and you can see the cavitating out of the matrix within this spongy bone. Well, this bone down here at the bottom, B, would be much easier to break than A at the top. So that's what osteoporosis is doing for you. I wanted to give you some common fractures. This is table 6.2. So my first one here is called comminuted. Look at all the pieces that we've broken this bone into. So in a comminuted fracture, the bone fragments into 3 or more pieces. And this typically does occur in the elderly. Okay, my next one up is a compression fracture. You can see this is taking place in a vertebrae. And so that's been too much force on that vertebrae, and we're literally crushing the bone. This is common. You can see it here, common in porous bones. Osteoporosis comes into play here. And so I've known people who have fallen or jumped and have crushed their vertebrae and have had this exact fracture. And we'll talk about those in class. The next one down here is a spiral fracture. And what happens in a spiral is we twist the bone, and you can see that we ended up with that jagged edge. I've got a story for a spiral fracture that I'll talk to you about. The next one down here, this is going to occur when someone is younger, because you see an epiphyseal. So someone has broken right on the growth plate. Not a good place to break a bone. This is going to cause some serious problems. But you got to remember that that growth plate is just cartilage. It's not solid bone. So you're going to see some breaks here. Okay, my last two, we have a depression. And in a depression, we've literally caked the bone in, and that doesn't always have to just occur in the skull. It's common in the skull, but this can occur in other places. And then finally, my last fracture here is a green stick. In a green stick, you've broken part of it, but not all the way through the bone. So it's basically a bend with a break. This really happens in young children when their bones are still forming. That's common there. Most adults, we don't see too many green sticks. We just tend to break all the way through. So this is the last of my common fractures, and this is the end of chapter 6.